So our today's lesson gives emphasis on application of rocket propulsion. So under this section, we are going to see some particular application like space launch purpose for spacecraft and for missile. So when we come to applications, so rockets are used for actually firework in ancient Chinese. Okay, and then missiles are followed, and other weapons, weaponry ejection seats. Actually, these ejection seats are also another important part of this rocket application because in most ejection seats in aircraft, we use some pyrotechnic application in order to separate the seat from the vehicle when there is some accident happen. So ejection seat is one of the rocket application. Missiles are all, and other weapons are also under this category. The pyrotechnic or fireworks is also the application of rockets. And the launch vehicles for artificial satellites also, human space flight and the space explorations are some of the application. So for this purpose, we use chemical rockets, which are the most common types of high power rocket. And in comparison to other air breathing engines, rocket engines have very specific applications, okay, which can be broadly classified into four application areas: space launch vehicle, spacecraft, missile, and some other miscellaneous applications. So when we come to space launch vehicle, it is just a space which carries some rocket, a vehicle which carries some rocket, which is propelled by by making use of chemicals stored in the rocket, and which is used to launch satellites or to carry payload from Earth's surface to space. That is the use of a space launch vehicle. The pilots, including the crew, means the human who launched with the rocket. So the crew members, the satellite equipments, the robotic spacecrafts, like those lunars and landers. Again, scientific probes, instruments. Again, it includes the power system. And the landers and rovers are also under this category. So space launch vehicle have a function to perform this all. The launch system includes launch vehicle. The vehicle itself is one of the launch system. The launch pad, the place where we are launching the vehicle. Again, vehicle assembly and fueling systems, range safety systems, and other related infrastructure. So that are called the space launch vehicle systems. Each space launch vehicles are designed and developed to perform some specific missions, such as like placing a satellite into certain orbit at some altitude from the Earth's surface. A mission to Moon is one of the mission, or to the Mars, or space exploration purpose. So that these are the application. So based on that, for example, India launched two operational launchers. One is the PSLV, what we call Polar Satellite Launch Vehicles, and GSLV, which is called the Geosynchronous Satellite Launch Vehicles. So these are some recent Indian space launch vehicles. So these are some of the space launch vehicles from mid-90s, because this space launch started in 1950s, and now it is almost to 17 years, especially more effectively within 17 years. So these are some of the space launch satellites which are launched to the space. So in United States, you can find this satellite, just Fergus XL, Tares, Titan 2, Delta 2, Atlas 2, Titan 4, and other space shuttles. So these are some of the American space shuttles. And these are some of the Indian space shuttle, like PSLV, GSLV, and the GSLV MK3 are the Indian space launch vehicles. So the Indian Polar Satellite Launch Vehicle and the geosynchronous satellite launch vehicles are the most common example. And we have also the Ethiopian satellite, which we call ET Smart RSS, which is launched by Chinese using the Long March 8. Chinese space launch vehicle was one of the best example. So that is the second Ethiopian satellite, which is launched by in collaboration with space science. So that is called ET Smart RSS. So is the one. So space launch vehicles have several kind of pilots. Among them, the military pilots are the one. Again, the civilian satellites also, and the space exploration and commercial and tourist application. So these are some of the pilots which, for example, the Long March 8 was launched in 20 December, which carries the Ethiopian second satellite. So that is the recent satellite actually. And other payload includes, actually this ETSR RSS is one of among the payloads which is carried by the Long March 8 of the Chinese. And with that, it carried other Chinese rockets also. Not only one rocket, but more Chinese rockets are also launched during that moment with the same launch. And the military application, which spans from just command and control satellites to reconnaissance satellites. And other civilian applications or launch vehicles are used for weather forecasting purpose, terrain mapping, and the mapping of the seismic zones for the earthquake-related phenomena, and the geopositioning satellites, GPS. And the communication satellites are some of the civilian application or the civilian launch vehicles. And the space exploration vehicles are also there, which is another area for which space launch vehicles are being developed. And the satellite for communication, the commercial purpose, and for the tourist purpose, like space stations. Space stations are satellites for the tourist purpose now. And those Elon Musk are building a space station, which is a comfortable space station for human being these days now. Okay, so actually, if you want to know the purpose of ETRSS-1, the first Ethiopian satellite, if you want to know information about that, it is satellite which is orbit height of 629 kilometers. It is in the height of 629 kilometers, which is orbiting, and it is only 65 kilograms, the first Ethiopian satellite. The second Ethiopian satellite is called ET Smart RSS, and its major issue is for Earth observation purpose, and which is just controlling the flood and the disaster prediction, and its mass is only 70 kilograms. Okay, these are just as information. How we can classify space launch vehicles? Space launch vehicles are classified based on different reasons. Among them, they can be classified as expandable and recoverable. One is expandable type. So expandable type is we cannot reuse it. But if it is a recoverable type, then we can reuse it. So expandable launch vehicles, or ELV, which are designed for one-time use. Once we launch them, we cannot bring them back. Therefore, with boosters that usually separate from their payload and disintegrate during atmospheric re-entry. So this is expandable type of space launch vehicle. So we cannot reuse this type of launch vehicles. So it may contain some booster phase. It can contain some payload. Spacecraft itself is here at the top of the front cone of the satellites, or nodes of the launch vehicle. So it is here only. This is the booster phase, and this is the sustainer phase, or FLR. That means forward load reactor is here. The launch vehicle adapter is here, which separates the spacecraft from the launch pad. So this is the simple example of expandable type. So expandable type is not reusable. So expandable launch vehicles are launch vehicles that can be launched only once, after which its components are either destroyed during a re-entry or discarded in the space. So this discarded in the space are those which left on the space are not good for launch vehicle. They can consider as a space debris. Okay, so they increase the space debris on the space, but in most cases, in launching phase, people do like that. They discard it on the space, or sometimes they destroy it. Again, reusable type are launch vehicles which with boosters, which are designed to be recovered intact and launched again. So, for example, this is one of the reusable launch vehicle. Look, this reusable launch vehicle, it launched to some space, and at some point separation will take place. Here you can see two vehicles. One is with green color, another is with some kind of yellow color. So it is launched from this point. This is the launch point, and then it goes to some height or some, and then here separation will take place. The blue, the yellow one will continue to required orbit, that is propelled ascent orbit. This is called the orbit called propelled ascent orbit, and this is only propelled ascent booster. It goes with only booster, so this carries booster rocket, and then this one will come back to Earth. So we can observe his two paths. One of the paths is the climbing path or ascent path. Another is coasting from this arc. It goes like this and coast to this arc, and then it comes to re-entry. Re-entry means atmospheric re-entry, because it go beyond atmosphere, so that it will come back to atmosphere here after sending the rocket to the required altitude. So this will come into gliding a return phase, and once it reaches to this point, engine ignition start, and it will fly like us aircraft. So around here, it is flight is just like us aircraft. So it is engine ignition starts here, and then propelled cruise will take place here, and then comes to landing here. So this is one phase. Another one will go like propelled ascent orbit, and then it goes to on-orbit waiting around here, okay? And then here, deorbiting will take place, and also gliding re-entry. It glides to re-entry also. So this kind of operation is a reusable launch vehicle. Both of the launch vehicles are reusable. This also comes down and glides again to the re-entry zone. Okay, so this is two main categories. Another classification is based on space launch vehicle classification based on propellant. On the propellant type, we call space launch vehicles can be used as solid and liquid engines. This is either together or individually in a single stage. So, for example, the non-cryogenic propellants and cryogenic propellants also are there. So we can categorize them using the propellant type. Non-cryogenic propellant, space launch vehicle with non-cryogenic propellant, or a space launch vehicle with cryogenic engines. So what are these non-cryogenic and cryogenic engines? We can discuss it later. Again, we can classify them by number of stages. That means in most cases, rockets are multi-stage. That means having more than one stage. Maybe staging can be in series or staging can be parallel, or maybe combination of the two. Okay, so based on stage, we call space launch vehicle can be classified as single stage, double stage, triple stage, and so on, based on the number of stages it contains. So the number of stages depends on the specific space trajectory, types of maneuver required, and types of the propellant used. So we classify them based on number of stages. Again, we classify space launch vehicle based on size or mass, the size of payload, the mass of payload or the vehicle, and the presence of crew, whether it is manned or unmanned. If it is if it is robotic type, then it is unmanned type. If it is having crew, then it is manned spacecraft. So this is kind of the way we can classify spacecraft. Now, staging in space launch vehicle. Before discussing this point, it is better to actually let's discuss it, and I will give you more clarification from the Word document which I have. So simply, when we call staging, it is just gestation of self-contained propulsion units known as stages. After the conception of their propellant, the crucial technique for improving the mass ratio of the space transport system was not using an environmental engine. Actually, this definition is not as appropriate for you. Let me give you some better definition for staging in the vehicle. Let me share another document. Look, let's come to this Word document. Is it visible for you, sir? Hello?
It is visible.
Is it visible?
طيب.
Word itaya? Okay. So rocket staging ስንል ምን ማለታችን ነው? The use of multiple stages within one rocket. So you can see from this figure, look, we have first stage, second stage, third stage, fourth stage, and the payload here. So this part is simply called the fourth stage, including the payload and the fourth stage. So it is 4-stage rocket. So you can see how the nozzles or the staging will take place. Each stage contains a number of nozzles or a number of engines. Actually, one engine with a number of nozzles. For example, maybe this can be nine nozzles or 8 nozzles maybe attached to this end. Maybe here it is 6, maybe here it is 4, maybe here it is only 1. So in this manner, staging will take place. So what is that multi-stage rocket? So multi-stage rockets are space satellites or launch vehicles that consists of 2 or more rocket stage, with each stage containing its engines and the propellants, which are detached post-launch, one after the other, till the pilot reaches its intended orbit or destination. So the main intention is to increase efficiency of the rocket and to bring the payload to the required destination. That is the main intention. Therefore, multi-stage rockets are predominantly used as they are much more cost-effective when compared to a single-stage rocket. Because in single-stage rocket, we may have very big propellant chamber, so the propellant is constantly decreasing, but the skeleton will remain with it, so that we have to remove the skeleton from the system or the dead weight of the structure, so that multi-staging is advantageous than that, or single stage rocket. So the what it is, yeah, you can simply see this. This is a good example of multi-stage rocket. Yeah. So maybe this staging can be made with parallel. You see here, there are parallel 9 solid boosters here. 9 solid boosters with first stage main ignition or main engine is there. In addition to the main engine, 9 booster rockets are attached at the periphery of the main rocket. Okay, so this is maybe the first stage, and the fuel tank of the first stage located here. This is second stage. Look, the nozzle design here of the second stage. So the fuel tank of the second stage is located here, and the engine is here. And this is payload position for payload. Okay, so you can see these things. Yeah, most of this maybe show you some dimensional, how we can dimension. Look, these are the delta 2, which is delta 2 79.5 type of rocket with it is some dimensions. What are the dimensions here? Okay, and what are the material? Look, so you can observe the payload also here. Payload is 2.9 meter in diameter, which is firing the payload, which is located in the third stage. Okay, this is third stage, this is second stage. And the avionics system also there. Yeah, so you can observe this thing. These are kind of expandable type of rockets. Okay, expandable rockets. So on that you can observe the first stage separation point, the second stage separation, second to third stage separation. Again, the satellite separation. Everything is safe. Look, this is boosters. These are small boosters. In addition to the main engine, there is main engine here. These are boosters, and then three of them discard at the same moment. Means the booster and the main engine of the first stage will discard at the first stage, and then after that the second stage will start ignition. Then once the second stage is discarded, then the third stage will take once the separation take place, the third stage will continue to burn, and then finally when we reach to some destination, the third stage also discarded, and our main satellite will be left. This is the satellite which is in the given orbit. or there are pre-defined orbits are there based on the mission requirement. So then after this skeleton also be discarded or separate. So this is kind of expandable type of satellites. The structure of launch vehicle consists of 2 or more rocket engines, with each stage containing its engine and propellant. So separately, each engine contains its engine and propellant itself. And the fuel required for a launch vehicle is large because the fuel is stored in multiple stages. And the payload will be placed, or that the payload can be the satellite or the spacecraft. So which is kept at the top of the launch vehicle. So as you see, at the top of launch vehicle, you can find the satellite or the payload. Here you can see MAP observatory is there. Here it is satellite is there. Okay. So it is placed at the safest point. Okay. The first launch, if the fuel of any stage is exhausted, look, if the fuel of any stage is exhausted, the empty fuel tank of the stage is detached from the launch vehicle body. And the fuel in the next stage is ignited. So this process is repeated until the payload is deployed or separated. By using the separation process, which takes place from bottom to top, the overall weight of the launch vehicle reduces, which helps the satellite or the spacecraft to together more, to have more space. Okay. Additionally, the overall fuel consumption is also reduced. So look, this is the way how stage separation will take place. Okay. Once this stage is fuel is fully consumed, the next stage will start igniting, and there are mechanisms which helps us to separate one stage from another that are called pyrotechnic mechanisms. The pyro mechanisms immediately initiate to detach the bolts or the attachments. Okay, so by that, the next stage will continue to flow to the required destination. So that is the multi-stage rocket process. So multi-stage rockets are separate using explosive bolts. This explosive bolt is known as pyrotechnic bolt or pyro device. And the point of contact that held the two stages of multi-rocket consists of some holes that is for bolt attachment. Referred, we can see here. These are some of the bolts which are separated at the point. Okay. So when observed from a cross-sectional perspective, the holes are filled with explosive bolts. There are closely to 300 points that can be filled with explosive bolts for each stage. And a fire is ignited from the upper stage of the rocket that acts as a catalyst for the explosive bolts, which goes off all around the stage and separates the lower stage that has exhausted it is or consumed all its fuel and is of no use for the upper stage. So which should be separated from the system by burning the next step. So that is the meaning of pyro separation. Actually, this is the mission, how, in which position we can separate each stage. This is just for Suez spacecraft. So the two US Russian crew of Suez spacecraft launch phase. This is the launch phase. The mission profile is like this. Okay, so there are three types of staging process. We have three staging process. One is serial staging. Like as we see, we have this thing before powering. So it is separated at some point, and the dead mass will be discarded here, the first stage. So this is having two stages, and it is separated. So upper stage firing is take place at this point. So this is called serial type of staging. Another staging is parallel staging. So in parallel staging, we have, you see here, these are the booster and this is the main engine. So the main engine and the booster are situated in parallel way. So these are discarded strap on or boosters, and the main engine will continue. So it is called sustainer. The next step is called sustainer, and the peripheral stages are called boosters. Okay. And another is the serial parallel staging, serial and parallel staging. So that is the third technique of staging. So we have a series staging here. Some first stage, second stage, third stage is there, and there is another boosters are there. So multiple rockets. So we can define this. This configuration stage, sustainer stage, attached to the booster. Okay, the sustainer is attached to the booster. That is detached once they are exhausted, and the sustainer takes the payload to considerable height, after which it detaches itself. And other stages that are in serial stacked are ignited. So this contains some serial stages, stage 1, 2, 3, 4, like that. And then there are some parallel stages together. So that kind is called the combination of serial parallel staging. Yeah, so multiple rockets, one discard from each stage after it has served their purpose, are made to crash towards to the Earth's surface, where they will burn up on re-entry. However, only the lower stage can be made to crash towards to the Earth. Why? Because that is operating near to atmosphere. The upper stage, rocket stage, will still pose a risk to the contribute towards to space debris. So these space debris are the discarded masses, which are just simply left in the space, which may not come to the Earth because they left in gravity-free vacuum. And then some of them also may make some orbiting around the Earth's orbit. So these space debris are the disastrous condition for the space flight, okay? Because they can cause some damage to the real spacecraft. So these are some of the multi-stage rockets having serial parallel combination. Yeah, you can observe some of this picture, which are taken from Google. So these are some of. So as a question, you can see here, what are multi-stage rockets? So answer is also there. Maybe. And what is the advantage of multi-stage rockets? That's why so the advantage of this type is each stage can be used